All right, good morning. All right. So last period, only one person was in class when I started class, and then now there's only 3 people, 4 people in class. Don't be late to class. It's disrespectful, it's rude, and you would never do that if we were at school. The other thing is make sure you finish what you start, because a lot of people's grades start taking a nosedive right now because everyone thinks school's over and school's not over. So don't ruin your grade by being late to class and not doing what you're supposed to be doing, which is finishing what you start in this class. All right, so tomorrow we're going to have an exam at 8 o'clock, and I want to talk about that first. Does anybody want to ask me any questions about the exam tomorrow? All right. Last time we were together, I taught lesson. Okay, so the exam tomorrow is 7172. And last time we were together, I taught 74. So anybody want to ask me any questions about anything? All right, well, today I'm going to start lesson 7.
How many problems are on the test?
There's 8. And depending on how we do in the Math Wizard teams today, I may give you some hints about the exam, but that won't be until later. So we're going to see in the Math Wizard teams if you're showing your face and working together, and then I might give you some tips seeing how we go with the teams, but I'm not doing anything before that. So anything else? Anybody want me to work a problem, or anybody have a question about anything? In 7.5, we're going to be looking at systems of inequalities, but today I don't even want to talk about systems of inequalities. I just want to talk about just inequalities in general. So I'm going to do part of the lesson, and then we're going to work in the Math Wizard teams on the globe problems for the exam tomorrow. So this one is systems of inequalities. And inequalities are greater than, less than, greater than or equal to, less than or equal to. But we're not going to be talking about systems today. I'm just going to give you a review of Algebra 1. So first of all, if we want to graph a linear inequality, I want to review this in case you never had it before. So what you're going to have is you're going to have a linear inequality. And the reason why we know this is linear is because it has an X and a Y. And the first that we're not going to worry about that inequality at first. So just a reminder that 2 is bigger than 1. So that's a greater than symbol. And 1 is less than 2, that's less than. So that's greater than, that's less than. And what we're going to do right now is we're not going to worry about the inequality. We're going to graph an equation. And then I will tell you the steps for graphing the linear inequality. All right, so first of all, I'll start writing the steps over here. So the first step is graph the equation. You're going to use slope-intercept form. If it's easy to graph, or if it's not easy, you're going to use a method called the X and Y-Intercept method. So you want to be able to pick a nice way to graph. So this is not easy to solve for y because there's -3, there's a 2x, it's just not easy. So I'm going to show you how to use this method. If it's easy to solve for y, you're going to use slope-intercept form where you find the slope and the intercept. And I'm going to do both of them. So let me do this one first. So when it's not easy to solve for y, we're going to use the X and Y-Intercept method. And what you're going to do is you're going to set x equal to 0. Well, when you set x equal to 0, 2 times 0 is 0. So you get with -3y equals 6. Don't worry about that inequality right now. So when you solve for y, you get y is equal to -2. So what you just found is you found the ordered pair 0 down 2, which is on the line. Now you're going to set y equal to 0. And when you set y equal to 0, you get 2x is equal to 6. X is equal to 3. And you just found another point on the line. So basically what we're going to do is we're just going to graph the 2 points and connect them. So we're going to graph this y-intercept, which is 0 down 2. And we're going to graph this x-intercept, which is right 3, 0. And all you do is connect the points. And it always works like this. So when you set x equal to 0, you're finding the y-intercept, 0 down 2. When you set y equal to 0, you're finding the x-intercept, which is right 3, 0. Make sure you don't mess up the ordered pair. Okay, now, in order to graph the inequality, that was the first step. The second step is decide if the line is dotted or solid. Now, dotted means that, well, let me just write it down. Greater than or less than means the line is dotted, and that means that the solutions cannot be on the line. For greater than or equal to or less than or equal to, the line is solid, and that means the solutions can be on the line. Now, here's the thing. When we have an equation, we graph a line. When you have an inequality, there's going to be infinite solutions. So the solutions aren't going to just fall on the line. They're going to fall either above the line or below the line. All right, so the third step, so in our problem, the line is solid, which means the solutions can be on the line. So the third thing we want to do is test a point in order to shade. So basically, shading means that we're showing the solutions. So let me show you how to do this. I'm going to write it down below here. So you can test any point you want. You can test 0, 0. You can test right one up one. You can test right one up 100. Test any point you want, just don't test it on the line. So I'm going to test 0, 0. And if 0, 0 falls on the line, you can't test it. So watch this. Now in this one, I'm going to take 2 times x minus 3 times y and see if I get a true or false statement. So 0 minus 0 is 0. Is 0 greater than or equal to 6? That's false. So that means do not shade him and all these other guys. And don't shade means shade the other side. So 0, 0 does not work. So that means all these solutions fail and all of these solutions work. So that means if you pick right 3 down 1, it's going to work. If you pick right 1 down 100, it's going to work. If you pick right 2 down 7.5, it's going to work. It means all of these solutions over here which is represented by the shading, it means they're going to work, and all these guys over here are going to fail. So these are the steps for the inequality. 3 steps. You're going to decide which graphing method you want to use. If it's easy to solve for y, use slope-intercept form. If it's not easy to solve for y, you're using this method called X and Y-intercepts, where you find the x-intercept and the y-intercept. After you graph the line, you're going to see if it's dotted or solid. And then you're going to pick a point on either side of the line to see if it's true or false. If it's true, shade it. If it's not true, like in this case, if it's not true, don't shade it. And don't means shade the other side. All right, anybody have a question about this problem? Would anyone like me to work another problem like this? The next problem I'm going to work is one with slope-intercept form, but does anybody want me to work another problem with this method?
Yeah.
All right. Okay, so once again, they're going to ask you to solve by graphing, and you're actually showing infinite solutions with this shading. So let me make up my own problem here. Let's just do greater than 0. Let's do greater than 4. All right, so this is not easy to solve for y because we'd have to subtract x and divide by 4, and it's like, forget it. So we're going to use the X and Y-intercept method. So we're going to set x equal to 0. You always set it equal to 0. So when you set x equal to, and by the way, we're not looking at the inequality right now. We're just looking at the equation. So we're not looking at the inequality till we go over there. You're just looking at the equation. So when you set x equal to 0, it ends up being 4y equals to 4. So when you divide by 4, you get y is equal to 1. So you just found the y-intercept, 0 up 1. Now you set y equal to 0. Well, 4 times 0 is 0. So you get x is equal to 4. And now you just found the x-intercept, right, for 0. So we're just going to graph the equation, which is 0 up 1 and right for 0. And you just connect the points. Okay, now we go to the steps and we say, all right, is the line dotted or solid? Now this is greater than, and greater than means the line has to be dotted. What does dotted mean? Does dotted mean that the solutions can be on the line or no?
No.
Right. Dotted means they cannot be on the line. They can come infinitely close, but they can't hit the line. Solid means the solutions can be on the line. All right, so here we go. So we did number 1, we did number 2. Now we're going to test a point. So you can test any point you want. Just don't pick one on the line. I'm going to pick 0, 0. So I'm going to put it into this. So x is 0 plus 4 times 0. Is that greater than 4? Is 0 greater than 4? That's false. So that means don't shade that. So that means if you're not going to shade 0, 0, that means all of these guys over here fail, and it means all of these guys over here work. So you shade it. The shading means it works. So that means right 1 up 4 works. It means right 2 up 7 works. It means 0 up 9 works. 0 up 100 works. It means that 0, 0 fails. It means 0 down 1 fails. It means right 1, 0 fails. Right 1 down 1 fails. All of these fail. All of those work. Okay, so let me just reiterate. Just worry about the equation first. Decide, are you using slope-intercept form? This is called the X and Y-Intercept method, where you're finding 2 points and connecting them. You're going to use this method when it's hard to solve for Y. When you're done graphing the line, you decide, is it dotted or solid? So this was greater than, so it's going to be dotted, which means the solutions cannot be on the line. Then you're going to test a point. Pick any point you want, just don't pick it on the line. So I picked 0, 0. So when I tested 0, 0 to this, I got a false statement. False means don't shade it. So don't means that none of these work. It's going to mean those work over there. Okay, any questions about this method? I'm going to do slope-intercept form now. All right, let's do one where it's easy to solve for Y. All right. So Y is greater than negative 2/3 X. Now, we want to use slope-intercept form. So I'm going to write the equation as negative 2/3 X. So remember slope-intercept form? The slope would be down 2, right 3, down 2, right 3, or up 2, left 3, up 2, left 3. And the y-intercept is 0. So the starting point is 0, 0. And I'm going to go up 2, left 3. Notice I'm out of room. So now I'm going to go down 2, right 3, and draw my line. Okay, what we just graphed was the equation. Now we're going to graph the inequality. So this right here means that the line is dotted, which means the solutions cannot be on the line. And now we're going to test a point. Now, see, I cannot test 0, 0 because the graph is on 0, 0. So I'm going to test right 1, up 1. So in this one, my y is 1. It's greater than negative 2/3 times x, which is 1. Is 1 greater than negative 2/3? Well, that's true. So what does that mean?
You can shade that area?
Yeah, it means shade him and all his buddies. So it means that's true, this is true, these are true, these are true, these are true. All of these points over here are true. And that's how you create the shading. Because all of those ordered pairs are true and all of these are false. So that means right 1 up 1's true. It means right 2 up 6 is true. Right 3 up 100 is true. It means 0 down 2 is false. Don't shade it. It means right 1 down 10 is false. It means shade all of those guys and none of those guys. So these are all true. These are all false. So you're going to graph the equation using slope-intercept or X and Y-intercepts. After that, you're going to look at the inequality. If it's greater than or less than, you make it dotted. If it's greater than or equal to or less than or equal to, you make it solid line. And then you test a point on either side of the line. If the point is true, shade it with all his friends. If it's not true, don't shade it, which means you would shade the other side. Okay, that is objective 1, which is just going over graphing linear inequalities. Any questions? Now remember, this lesson is solving systems. So you're going to have to graph more than one of these in one problem. Right now, we're just graphing an inequality and reviewing. All right, now there's some special cases where you don't have to do a whole lot of work. And I want to show you those. And by the way, when you take your college math class, you can use your calculator to shade. So remember, there's a lot of technology you can use. My philosophy is I'm teaching you how to do the math so you can use the calculator. Of course you want to use the calculator. But what I found out, that a lot of students who don't understand anything try to get the calculator, and they're using the calculator wrong because they don't know conceptually what's going on. So hopefully what we're trying to do here is we're trying to get you to understand the concepts so you can use the calculator. Remember, the calculator is only as good as the user. All right, so check this out. Now, this is a special case because the line is a vertical line. So we're not going to waste a lot of time. We're going to draw the graph. And we know that this is a vertical line through x equals 2. So we're not using slope-intercept form. We're not using x and y-intercepts. We're using common sense. So this is a vertical line. So now we look at the problem and go, okay, well, the line is dotted because it's strictly greater than. And now let's think about this. This says that all the solutions are greater than. So doesn't greater than mean to the right, and wouldn't less than mean to the left? So all the solutions are greater than. We're not gonna test a point or anything. We're just gonna use common sense. So this says that all the solutions are greater than 2. So we're done. Another special case would be something like this. Well, we're not going to use slope-intercept form or the other form. We're going to use our brains and say, okay, this is a horizontal line through y equals 1. So this is a horizontal line through y equals 1. And now we say, okay, well, it's solid. And doesn't this mean all the solutions are below 1? All the solutions are less than or equal to 1. So wouldn't less than or equal to 1 look like this? And wouldn't greater than or equal to go above? So we're going to use common sense on these problems that have just an X. So we're going to look at this and go, this is a vertical line. It's dotted. And we're going to shade greater than to the right, less than would be to the left. This guy is a horizontal line. It's solid because it's less than or equal to, and less than means below the line, greater than would be above the line. Anybody have a question about these two problems? Okay, I'm going to do one more problem, and it involves the circle. So I'm going to give you a crash course on the circle. I think I've talked about the circle before. So the equation of the circle looks like this. And in order to graph the circle, all you need is the center, which is HK, so there and there, and the radius, which is R. So for example, if you have x squared plus y squared equals 4, this really means this. It means x minus 0 quantity squared plus y minus 0 equals 4. So that means your center is at 0, 0, HK. And your radius, we know that r squared is equal to 4. So if you took the square root of both sides, you get plus or minus 2. And since the radius is the length, we would have to just say r is equal to 2. So watch how easy this is to graph. The center is at 0, 0. And the radius, you're going to go up to and make a point, right to and make a point, down to and make a point, left to and make a point, and draw the circle. Now we're going to have inequalities. I'm just showing you how to graph the equation of the circle. Let's do another one. Now, if you were going to find the center would be right 1, down 2. And the reason why is because this would be right 1. This would be y minus a negative 2, which means down 2. So don't put positive 2. Just like the parabola. Just like, you know, all the other functions we looked at doing transformations. The radius is r squared equal to 9. So when we take the square root, we get plus or minus 3. So since the radius is the length, it would be 3. So we draw the graph. The center is at right 1, down 2. And what we do is we go up 3 and put a point, right 3 and put a point, down 3 and put a point, left 3 and put a point, and draw the circle. And that's the equation of the circle. Okay, does anybody have a question about this? Because now we're going to graph an inequality. All right. Now we're going to follow the same steps as the linear inequality, but let's write down the problem. They want us to graph x squared plus y squared is less than or equal to 9. So what we're gonna do is we're gonna graph the equation and worry about the inequality later. So here we go. So remember what I said, this is x minus 0 quantity squared plus y minus 0 quantity squared. This is a circle. So the center is at 0, 0. And the radius is r squared equals 9, which means the radius is plus or minus 3. And since it's a length, it's positive. So now we graph the circle. We graph the equation of the circle. So we have 0, 0, up 3, right 3, down 3, left 3. And now we go through the steps for the inequality. So here we go. This is less than or equal to, which means the boundary is solid. If it was strictly less than, notice I'm not calling it a line. It's not a line, it's a boundary. If it was less than, we would make it dotted. Now we're going to test a point. I'm going to test 0, 0, which is here. If it works, I'm going to shade inside the circle. If it fails, I'm going to shade outside the circle. So here we go. We have 0 squared plus y squared. Is that less than or equal to 9? Is 0 less than or equal to 9? That is true. So that means shade him and all his friends. The reason why we didn't shade this is an equation. This is an inequality. So the solutions for this guy are on the boundary. The solutions for this guy are inside the boundary. Okay, do you want me to do another circle inequality?
Yes.
All right. All right. I'm going to make this up. Let's say we have x minus 2 quantity squared, and we have y plus 1 quantity squared is greater than 4. So the first thing we do is we look at the equation and don't worry about the inequality. So the center would be right 2 down 1, right? Right 2 minus a negative would be down 1. And the radius would be r squared equal to 4. The radius is not 4. The radius squared is 4. When you take the square root, you get plus or minus 2. So the radius is a length. So now we're going to graph the equation, and then we'll worry about the inequality. All right. So we're going to graph right 2 down 1. And to graph the circle, we're going to go up 2 from the center, right 2 from the center, down 2 from the center, and left 2 from the center. And we're going to graph the circle. Now we look at the inequality. It's strictly greater than. So that means the boundary of the circle is dotted, which means the solutions cannot be on the boundary. And now we're going to test a point. Okay, now look up here real quick. You see how the graph is kind of hitting 0, 0? I'm not going to pick 0, 0. It's too dangerous. So I'm going to pick a safe point. Like I'm going to pick right to 0. So when I pick right to 0, I'm putting it into the top. So I get x is 2 minus 2 quantity squared plus y is 0 plus 1. Is that greater than 4? Is 0 squared plus 1 squared greater than 4? Is 1 greater than 4? False. That means don't shade it. So notice how I put them in there so I can remember if I'm testing in or out. So do not shade that. So that means shade everybody on the outside. So that means everybody on the outside of the circle is a solution and everybody inside is not. So you pick any point on the outside and it's going to work. Anything on the inside is going to fail. All right, anybody have any questions about how to graph the equation of the circle or how to graph the inequality?
So when you test a point, it has to be in the circle?
Yeah, you can test a point outside the circle. So if let's say I test 0 up to. If I test 0 up to, it better be true, right? Because I shaded it. You can test any point you want. So I'm going to test it. So this would be 0 minus 2 quantity squared plus 2 plus 1 quantity squared. Is that greater than 4? Is negative 2 quantity squared plus 3 squared greater than 4? Is 4 plus 9 greater than 4? Is 13 greater than 4? Yes, that's true. And that's why we shaded it. So you don't have to pick a point inside the circle. You can pick any point you want. If it's true, shade it. If it's not true, don't shade it. Does that make sense or no?
Yeah.
Just here's the thing you can't do. Do not pick a point on the circle. So that's why I didn't pick 0, 0, because the graph is coming really close to it and that's too risky. So pick a point that's not near the boundary. You understand?
Yeah.
Okay. All right. So I'm going to stop there today. So basically, I just showed you how to graph linear and circle inequalities. That's not this lesson. The lesson is solving systems. So let me show you what's going to go down. And that's why I'm reviewing this, because I'm assuming you know how to do this. All right, so let me erase this. So here's what this lesson is. Don't write this down, just pay attention. You're going to have a system where you have a quadratic. And then you might have a circle. Well, what you're going to have to do is you're going to have to graph the quadratic and know that it's dotted. And let's pretend it's shaded on the inside. Well, this is a circle with a radius of 2 at 0, 0. So this circle is going to have a solid boundary. And let's say it's shaded on the inside. Let me do another color. Well, the solutions to the system aren't just the black. The solutions are not just the blue. The solutions are going to be where you see black and blue intersecting. So the parabola was shaded on the inside. The circle was shaded on the inside, but the solutions are solid, dotted. Those are the solutions. Because that's where you see black and blue. So that little piece is what makes these true. So not only do you have to graph the quadratic inequality, you have to graph the circle inequality, and you have to see where the two graphs are intersecting, because those are the solutions. So like I said, it's not where it's black. That's the black is what makes this true. The blue is what makes this true. You have to see black and blue is where they make both true. So that's what we're doing in this lesson. We're not just graphing a circle inequality or a linear inequality. We're graphing a system. All right, any questions? All right, so it's 11:32 and class is over at 12:10. So at 12:05, you're going to come back and I'm going to either give you hints for the exam or I'm not. So what this is dependent on is in the Math Wizard teams, if you show your face, if you're working in the online problems, if you're working together, then at 12:05, I'm going to give you some hints about the exam. Now, I'm not going to go into the teams and say, turn on your video, work together. I'm not doing any of that. So you're either doing what I want or you're not. If you're doing what I want, I'll give you hints about the exam. If you're not doing what I want, you're on your own. Take a guess what's on the exam tomorrow morning. Okay? All right, I will see you in your Math Wizard teams, and I will be taking attendance in there. I'll see you back here at 12:05. All right, and we're back at 12:05. All right. You did a good job today, and I want to let you know what you should study for the exam. So if you want to write this down. All right, in 7-1, make sure you know how to do 1, 5, 21, 31, 37. In 7-2, make sure you know how to do 1, 5, and 7. There are 8 problems on the exam, and there are no word problems.
What's for 7.1 again?
1, 5, 21, 31, 37. And 7-2 is 1, 5, and 7. It's a total of 8 questions. Obviously in 7-2, 5 and 7, those are more heavily weighted because they're more difficult problems. So make sure you show your work. Make sure when it says use substitution, you write them side by side. When they ask you to use addition, you stack them. All right, anyone want to ask me any questions about anything or any problems? Last call. Any questions or problems? Anybody want me to work anything?
For 7.2, the 5 and 7, are we gonna, if there's like, cause you know how they're like long questions, do we have to write all of that and put on the picture when we send it to you, or?
Yeah, you have to send your scratch paper with the work shown.
Okay,
And that's because with all these programs out, the ones where you can like put the problem in and it'll give you the answer. The only way I can tell if you legitimately did it is if you show the work. So you must show all the work, you won't get credit for the problems. Right? You know what I'm talking about? Those programs that are out where you can put the problem in that gives you the answer.
yeah,
Yeah, so I have to see the work to know that you legitimately did it. Otherwise, if there's no work, you get a 0 for the problem. All right, anything else? All right, well, listen, good luck tomorrow. You only have 8 problems to worry about. If you get stuck on something, hopefully you can contact one of your classmates, try to work a problem together. You guys can go into the wizard teams on your own later and work on things. But anyhow, good luck on the exam, okay? All right, good luck. All right, and I'll see you Wednesday. All right, you guys, bye-bye. Have a good day.